Let's discuss impulse. Remember, we said that the net force is equal to the rate of change of momentum. Okay, and then we know that F net is equal to change in momentum divided by change in time, delta P over delta T. This equation may be arranged. Let's say if we multiply both sides by delta T, what do you get? Say F net times delta T is equal to delta P over delta T times delta T. Right, see that we have multiplied both sides by delta T, then delta T divided by delta T, we get what? We get 1 there, and then we remain with this. This product, F net times delta T, is called impulse. So impulse is the product of the net force acting on an object and the time the net force acts on the object. The product of F net and time, thus impulse. But if we check, this impulse is equal to delta P. So what does that mean? It means that actually impulse is equal to change in momentum. That's what it means. Impulse is equal to change in momentum. Therefore, F net times delta T is the impulse, which is equal to the change in momentum. Then impulse is a vector quantity. Since F net is a vector quantity, so it means impulse is also a vector quantity. And then impulse is in the direction of the net force. Actually, the net force exerted on the object, impulse, and change in momentum, all these three are in the same direction. So the net force, impulse, and change in momentum are all in the same direction. So this relationship, F net times delta T is equal to change in momentum, is also known as the impulse momentum theorem. Is also known as the impulse momentum theorem. According to the impulse momentum theorem, the impulse experienced by the object equals the change in momentum. In simpler terms, we just say impulse is equal to change in momentum. That's what it means. If change in momentum is constant, net force is inversely proportional to time. We use this a lot when it comes to application of impulse on safety considerations. If change in momentum is constant, net force is inversely proportional to time. So what does this mean? Inversely proportional to time. What does that mean? It means that if the time increases, the net force decreases. Right, let's go back to this one, which says F net is equal to delta P over delta T, like this. So delta T is the denominator. If the denominator increases, then the value of the fraction what? Decreases. So from here you can see that if time increases, then F net is going to decrease. If time decreases, F net increases. You see that? So if you increase time, the force, the net force will what? Will decrease. So we're going to talk about this a lot when we talk about the safety considerations. We're going to do a few examples in our next tutorials.